Hi, this is Rebekah Evans from the Space Weather Center located at NASA Goddard Space Flight Center. In this video, we highlight the May 17th, 2012 space weather event that included a flare, a coronal mass ejection, a solar energetic particle event, and the first ground level enhancements since 2006. On May 5th, active region 1476 rotated into view. It was smaller than the incredible active region 1429, but its complicated structure gave it potential for generating lots of activity. It did not disappoint. It fired off 10 M-class flares and 1 O-type CME over a 7-day period. On May 17th, as it started to go behind the solar disk, it flared and released a fast CME. This storm triggered the acceleration of particles near the Sun. Signatures of these particles were detected on the ground, indicating this space weather event accelerated particles to very high energies. This was the first GLE since 2006, which makes active region 1476 record-setting for producing the first GLE of the new solar cycle. Here we see the signature of those relativistic protons, a sudden spike in the count of neutrons as measured from Finland. The question that arises is, why did this flare and this CME result in a GLE? They were not as impressive as the two X-class flares and fast CME from active region 1429 on March 6th, and the flare was not significantly stronger than the other M-class flares from this region during the 12 days prior to May 17th. The first thing is that the active region was in a great location. It was magnetically connected to the Earth, meaning that the accelerated particles had a direct path here. Second, the flare lasted for an unusually long time. The long duration of this moderately strong flare means that it had a lot of time to accelerate particles. The CME that went with this flare was also special. It first appeared around 2 UT while the flare was still ongoing. The CME's high speed means it formed a shock wave ahead of it, and shock waves are known to accelerate particles to high energies. So both the flare and the CME work together to generate the large number of relativistic protons which are required for a measurable GLE. Here is the projected path of the CME. The simulation shows an impact at Messenger and Stereo A spacecraft and a glancing blow at Earth. Finally, here we see the arrival of the CME at Stereo A and at Earth. This has been a special report from the NASA Goddard Space Weather Center. Thanks for watching and have a great day.
All of the data in this video is accessible from our Integrated Space Weather Analysis System, located at iswa.gsfc.nasa.gov.